Welcome to Session 1. Build a Mastery Baseline. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to classify errors by cause, to turn a mistake into a specific correction, and to schedule retrieval-based review. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. A useful baseline explains why an answer failed. Use this visual structure. Evidence is greater than cause, is greater than correction, is greater than delayed retry. Read every symbol and label before calculating. The first goal is to classify errors by cause. Connect it to the second goal. Turn a mistake into a specific correction. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Record the evidence, not a vague feeling. State the target and preserve its units or conditions. Step 2. Classify concept, setup, execution, or decision. Use a separate line so signs, factors, and labels remain visible. Step 3. Write one observable prevention step. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Rejoin after a delay and compare reasoning. Verification is part of the solution because it tests the answer from another direction. Signal 1 is, the relationship is unknown. Respond by remembering. Repair the concept. Name the response before calculating. Signal 2 is, the model is wrong. In that case, repair the setup. The form tells you which tool fits. Signal 3 is, the work is right, but arithmetic fails. Remember, repair execution. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. Which result deserves the earliest review? Restate what is requested before touching the choices. The first move is, record the evidence, not a vague feeling. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. High minus confidence misses often reveal a stable misconception. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Write one observable prevention step. The explanation supports one option without relying on its position. The mathematical conclusion is a high minus confidence wrong answer. State it with any required units, interval notation, or restrictions. The final answer is a high minus confidence wrong answer. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Solve a fresh parallel problem without notes. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. Which statement best describes transfer? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. First hint, transfer means selecting and applying knowledge beyond the practice surface form. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is applying a learned relationship in an unfamiliar minus-looking problem. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to classify errors by cause. Combine that with the discipline to turn a mistake into a specific correction. Finish by remembering to schedule retrieval-based review. A result becomes dependable only when the method and verification are both clear. Reflection. Which recurring mistake can you now describe as a behavior rather than a label? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session.